Welcome to The Explainer. Today we're talking about something that's, well, kind of a silent killer in software architecture. It's that one tiny change that can somehow bring down an entire system. So how do we architect our way out of that? How do we make changes without, breaking everything? All right, let's kick things off with a question that I guarantee keeps every development team up at night. On the surface, it seems so simple, right? But the consequences? They can be absolutely massive. How on earth can one tiny little data change trigger a total system meltdown? Okay, just imagine this for a second. A developer pushes what looks like a super simple change, maybe just adding one new field to a user profile. But that little change, it starts to ripple out. It touches dozens of services, maybe running in different clouds, and bam, it kicks off this devastating chain reaction. All of a sudden, your most critical services are failing, and you're in the middle of a full-blown multi-cloud outage. So this incredibly dangerous process, it actually has a name. It's called schema evolution. It's basically the challenge of changing the structure of your data and your APIs over time. And look, if you get it right, your system evolves beautifully, gracefully. But if you get it wrong, well, you're looking at a catastrophe. So mastering this isn't just a nice to have, it's absolutely essential for survival in modern systems.
Okay, so how do we actually prevent this kind of meltdown? The answer isn't to just stop changing things, right? That's not realistic. It's about changing them smarter. The key is having the right toolkit, a specific set of strategies to manage all this complexity. Let's dive into your three main lines of defense.
So your toolkit really boils down to three core strategies. You've got backwards compatibility, versioning, and contract testing. Each one of these plays a really distinct but, complementary role in helping you manage change safely across all those distributed systems you're running. All right, first up is backward compatibility. The best way to think about this is as your fundamental safety nets. The core idea is really simple. Any new version of a service has to be able to understand requests and data from the older versions. This makes sure that when you roll out an update, you don't immediately break every single service that depends on it. It's our first line of defense. Next up, we've got versioning. And if backward compatibility is the safety net, then versioning is kind of like your control panel. By creating these explicit, numbered versions of your API, like a V1 and then a V2, you're giving other teams the power to upgrade on their own schedule. They can stick with the old version until they're totally ready to handle the changes in the new one. No surprises. And finally, our third tool, contract testing. Now this is your early warning system. It's basically an automated process that is constantly checking to make sure that a service providing an API and a service using it can still talk to each other correctly. It's designed to catch those integration-breaking changes way before they ever have a chance to hit production. Okay, so we've got our tools. Now let's put them into practice and see how they all work together in a pretty high-stakes scenario. We're going to walk through a real-world example, making a change to both an API and a database that spans multiple clouds. So, here's the most crucial point, the thing you absolutely have to remember. You have got to resist the temptation to just change everything all at once. That big bang approach, that's exactly how outages happen. The safe, resilient path is always a phased rollout, a really carefully orchestrated sequence of steps. And this right here illustrates that safe path perfectly. Just look at this. Step 1, you add the new field to the database, but, and this is key, you don't use it yet. It's a totally non-breaking change. Then, for step 2, you deploy a new API version that actually writes to both the old and the new fields. This keeps everything in sync while you transition. Only after, and I mean only after, every single consumer has migrated over to the new API, do you move to step 4 and update the API to read only from the new field. And finally, when you've confirmed that nothing is touching that old field anymore, then and only then can you safely remove it. And what's the result of all this? Zero downtime, zero data loss. That's how it's done. So, after seeing the tools and walking through that whole process, what's the big lesson here? What's the fundamental takeaway that really separates the resilient, modern systems from the ones that are just, fragile? It all really boils down to a major shift in mindset. You have to accept that change is constant. It's inevitable. So instead of trying to prevent it, you plan for it. You never make a breaking change in one single step. And you always use that powerful combination of backward compatibility, versioning, and contract testing. The goal isn't to build some static, perfect system that never changes. The real goal is to design a system that can evolve gracefully from day one. And that really leaves us with one last crucial question that every single architect and engineer should be asking themselves. As you look at the systems you're building today in this world of nonstop, constant change, is your architecture built to be rigid, built to eventually break, or is it built from the ground up to evolve?